Next topic we're going to see is page replacement. So the idea of page replacement is when you're bringing some data from the virtual memory onto the physical memory, you need to put it somewhere in the physical memory, and if your physical memory is full, you need to remove some existing data and replace that with the data you're newly bringing in, right? So that is called page replacement. You remove a page you don't want from the RAM and bring in a page that you need. So it is analogous to cache replacement, which we've studied in computer organization, right? So your cache memory is full now. You'll remove something from the cache and then you'll put the data which you newly brought in. Same logic is what page replacement is about. So what happens is you find the location of the desired page on secondary storage. So from your secondary memory or logical memory or virtual memory, you find out what data you want to bring in. Now find a free frame in the main memory. So remember that physical memory is divided into frames and logical memory into pages. This terminology we have discussed. So in your RAM, you will look for a free spot. So for example, if this is your RAM, these gray locations are free. So if there is a free location, you will take this data, you will directly put it in there. If there is no free location, meaning if your RAM is full, then you have to clear one of the existing spots. You have to kick out data from one of the existing frames, and you have to put this newly brought in data into that frame which you just cleared. So how do you so the frame which you're clearing, the frame which you choose to replace, the data which you're kicking out from your RAM is what is called a victim frame. So there are specific algorithms to select the victim frame, which we will be looking at in a minute. So yeah, you choose if your RAM has some empty space, you will take some data from the virtual memory, put it directly in that empty space. If there is no empty space, you have to clear some space, then you put this data there, then you continue execution as usual. So that is page replacement. Now we are going to look at how to select the victim frame. So assuming my RAM is full, I want to clear a frame, I want to remove some data from my RAM so that I can make space for the data I've just brought in. Now how do I decide which data to clear or which frame to clear from my RAM? For that we have page replacement algorithms, which page or which frame to remove. So we're going to look at those now. So the first algorithm is FIFO, first in first out. So the oldest page to have been brought in to the RAM is the one that will be kicked out first. So when your RAM is full, whatever was the first page which you brought in, that's the one which is going to be removed. So we have this example, we'll work it out and see how this works. So look at this example. Now this represents your physical memory, right? So for simplicity, we are considering a physical memory where you have only 3 frames or 3 locations, meaning at max you can store 3 pages. These numbers over here are different page numbers from your virtual memory. So initially my RAM is empty, there are 3 frames. So I want page number 7. It's not there in my RAM, there's nothing in my RAM, so I'm bringing a 7 inside. Next, I want to use page 0. Again, there's nothing in my RAM except 7, so I bring in a 0. Next, I want to use 1, which is not already there, so I bring in a 1. Next, I need page number 2 of some process. I need to execute it. I need to bring it into my RAM. I look at my RAM, it is full, so there is no empty space now. So I have to kick out one of these. I have to kick out either 7 or 0 or 1. Now because I'm doing FIFO, the first page which I brought into this RAM, or the oldest one to have entered, will be the one to be kicked out. So 7 was the first I brought in, so I'll kick out 7 and I'll put a 2 there, 201. Now I want 0, which is already there, so there's no kicking out, luckily. Now I want a 3, 3 is not there. I have to kick out the oldest page to have been brought in, which was a 0. So I'll kick out the 0 and I'll put a 3, 2, 3, 1. Now again I need a 0, which is not here. The oldest page here is a 1, so I'll kick out the 1, it becomes a 2, 3, 0. Now I need 4, again 4 is not here. The oldest of these 3 was the 2, so I'll replace the 2 with 4, 4, 3, 0. Again I need 2, 2 is not here. 3 was the oldest, replace 3, so 4, 2, 0. Again I need a 3, 3 is not here. 0 was the oldest, so replace that 0 with a 3, 4, 2, 3. Again I need 0, 0 is not here. The oldest was 4, replace that 4 with 0, 0, 2, 3. I need a 3, 3 is already here, it's a page hit. I need 2. Again 2 is already here. It's also a page hit. Now I need 1. 1 is not here. The oldest of these was the 2. So remove the 2 and put the 1. 0, 1, 3. Again I need a 2. 2 is not here. The oldest is 3. So remove the 3 and put the 2. 0, 1, 2. I need 0. Page hit. It's already there. I need a 1. Page hit. It's already there. Now I need a 7. 7 is not here. The oldest of these was the 0. So remove the 0 and put in the 7. 7, 1, 2. Now I need 0. 0 is not here. The oldest was this 1. Remove the 1. Put in the 0. 7, 0, 2. I need 1. 1 is not here. The oldest was the 2. Remove the 2 and put in the 1. 7, 0, 1. So the basic idea of FIFO is whichever was the first or the earliest page to have entered, that is the one you will kick out in case you need space. So this is your RAM. Each segment is called a frame. We've taken the simple example where you have 3 frames. These are the page numbers from the virtual memory. The tick means what you're looking for is present in the RAM. It's a page hit. The circle means it was not there, so you had to kick someone out and bring this in. So that's a page miss or a page fault. So that is the FIFO page replacement algorithm.